Observe the nature around us. It has an order to it. Most of the things around us, including our own body, follows a certain order. Now, take a look at some of the objects around us. The arrangement of petals and seeds of a sunflower has a certain pattern. Even the spirals around a pine cone follow a certain pattern, and our own human heart, beat 2, follows a certain order. Such patterns or orders form a sequence. Thus, a serial arrangement in which things follow a logical order or a recurring pattern is called a sequence. Take a look at this real-life situation. John's dad has been marking this growth chart on his birthday for the last 6 years. Do you notice any pattern here? Observe the circled numbers on the growth chart: 84, 92, 100, 108, 116 and 124. We see that the numbers are increasing in a certain pattern. Every number is bigger than the previous number by 8. Now, take a look at another situation. John has subscribed monthly subscriptions to 4 magazines, and he has a whole lot now. Do you notice any pattern here? Yes, the number of magazines are increasing every month. That is 4, 8, 12, 16. The difference between 2 consecutive numbers in this series is 4. Now, observe the set of numbers on the growth chart: 84, 92, 100, 108, 116 and 124, and the number of book sets: 4, 8, 12, 16 and so on. Both follow a certain pattern called sequence. A sequence in which each term except the first is obtained from the previous by adding a constant value is called arithmetic progression. Now, let us take a closer look at arithmetic progressions formed in the examples given below. YB adds Rs 50 every month to his piggy bank. His savings each month are 50, 100, 150, 200, 250. The temperatures recorded for a week for the city are 5, 5.3, 5.6, 5.9, 6.2, 6.5 and 6.8. A set of 5 even numbers: 2, 4, 6, 8 and 10. A set of natural numbers: 1, 2, 3, 4, 5, 6. Each of the numbers in the list is called a term. Can you write the next term for the sequence? Yes, by following a pattern or rule. Now let us write the rule for each of them. In the first situation, each term is 50 more than the term preceding it. We see that successive terms are obtained by adding a fixed number to the preceding term. The fixed number is called the common difference of the AP. Thus, common difference D is added to any term to get the next term of the sequence. Now, observe the sequence of numbers in examples 2 and 3, which have only a finite number of terms. Similarly, the arithmetic progressions in examples 1 and 4 do not have a last term, that is, they do not have finite numbers of terms. An arithmetic progression that has a definite set of terms is called finite arithmetic progression, and an arithmetic progression with no last term is called an infinite arithmetic progression. Now, let us see some examples in real life that form arithmetic progression. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Suppose we assume that V amount of air in the beginning. We get a series V, 3V by 4, 3 by 4 square V and so on. Here, the difference between 2 consecutive terms is not a constant, so it is not an AP. What is the simple interest earned on Rs 100 every year at the rate of 5% per annum for 5 years? We know simple interest is given by P into T into R by 100. Substituting the known values and simplifying, we get 100 into 1 into 5 by 100, that is equal to rupees 5. Here, rupees 5 is the interest earned every year. So the series is 5, 5, 5, and the common difference between any two terms is 0. So it is an AP. Observe the set of prime numbers. The series here is 1, 2, 3, 5, 7. Here, the common difference between the two consecutive terms is not constant, so it is not an AP. A taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for additional kilometer. Here, the series is 15, 23, 31, 39. Here, the common difference is 8, so it is an AP. John's collection of magazines has been growing every month. Can you find out how many magazines he will have at the end of the 50th month? We know that we can find the 50th term if we start from the first term and compute the successive ones by adding the common difference, but this will take a long time. Is there a simpler way to solve this? We know that at the end of the first month, John had 4 magazines and he has been getting another 4 every month. So let us denote the first set as A1 and additional magazines every month as D. So by the end of the second month, he has A2 number of books. Similarly, by the end of the third month, we have A3 number of books when 2D gets added, and by the end of the fourth month, we have A4 number of books as 3D gets added. We can mathematically write this as A2 is equal to A1 plus 1D, A3 that is equal to A1 plus 2D, A4 is equal to A1 plus 3D. Taking this to the nth term, we get An is equal to A1 plus n minus 1D. Thus, the nth term of an AP with first term A and common difference D is given by An is equal to A1 plus n minus 1 into D. At the end of the 50th month, the number of magazines John can have is represented as A50. Now, using the formula An is equal to A1 plus n minus 1D, we get A50 is equal to 4 plus 50 minus 1 into 4, that is equal to 4 plus 49 into 4, that is equal to 4 plus 196, that is equal to 200. So, John's collection of magazines should have grown to 200 at the end of the 50th month. Find the sixth term from the end of the arithmetic progression 17, 14, 11 up to minus 40. We know that the nth term of AP is given by expression An is equal to A plus n minus 1D. Substituting the known values and simplifying, we get 17 plus n minus 1 into minus 3 is equal to minus 40. Taking the constant terms on the other side, we get n minus 1 into minus 3 is equal to minus 40 minus 17. N minus 1 is equal to minus 57 by minus 3, which is equal to 19. N is equal to 19 plus 1, that is equal to 20. So, the number of terms for this AP is 20. Then, the sixth term from the end is going to be 20 minus 6 plus 1, which is also the 15th term from the beginning. Substituting the known values in the formula for the nth term, we get sixth term from the end is equal to 17 plus 15 minus 1 into minus 3, that is equal to 17 minus 42, which is equal to minus 25. Thus, in general, if there are m terms in an AP, then the nth term from the other end is going to be m minus n plus 1th term from the beginning. The 10th term of an AP is 44 and its 15th term is 64. Find the arithmetic progression. Here, it is given that the 10th term A10 is equal to 44 and the 15th term A15 is equal to 64. We know that the nth term of an AP is given by AN is equal to A plus N minus 1D. So, A10 is equal to A plus 10 minus 1D. 44 is equal to A plus 9D. Consider this as equation 1. Similarly, A15 is equal to A plus 15 minus 1D. 64 is equal to A plus 14D. Consider this as equation 2. Subtracting equation 1 from 2, we get 20 is equal to 5D. Solving for D, we get D is equal to 4. Substituting D is equal to 4 in equation 1, we get 44 is equal to A plus 9 into 4. Solving for A, we get A is equal to 44 minus 36, which is equal to 8. Which term of an AP 5, 15, 25 will be 130 more than its 31st term? In the arithmetic progression 5, 15, 25, the first term is A equals 5. The common difference D is equal to 15 minus 5, which is equal to 10. We know that the nth term of an AP is given by AN is equal to A plus N minus 1D. Substituting the known values to find the 31st term, we get A31 is equal to 5 plus 31 minus 1 into 10, that is equal to 5 plus 30 into 10, which is equal to 305. According to the problem, the nth term of AP is 130 more than its 31st term. So, AN is equal to 130 plus A31, that is equal to 130 plus 305, that is equal to 435. So, A plus N minus 1D is equal to 435. Substituting the known values, we get 5 plus N minus 1 into 10 is equal to 435. N minus 1 is equal to 435 minus 5, which is equal to 430. N minus 1 is equal to 430 by 10, which is equal to 43. N is equal to 43 plus 1, which is equal to 44. So, the 44th term of this arithmetic progression will be 130 more than its 31st term. Determine the first negative term of the sequence. For the given AP, 20, 19 1 by 4, 18 1 by 2. A is equal to 20. D is equal to 19 1 by 4 minus 20, that is equal to minus 3 by 4. Let us assume that AN is the first negative term. We know AN is equal to A plus N minus 1D. Substituting the known values, we get AN is equal to 20 plus N minus 1 into minus 3 by 4. That is equal to 80 minus 3N plus 3 by 4. Since AN is a negative term, 80 minus 3N plus 3 by 4 is less than 0. Multiplying the whole equation by 4, we get 80 minus 3N plus 3 is less than 0. That is, 3N is greater than 83. N is greater than 83 by 3. N is greater than 27.67. Rounding off the value of N, we get N is equal to 28. Thus, the 28th term of the sequence 20, 19 and a quarter, 18 and a half will be the first negative term of the given sequence. Now, let us try another problem. Find the number of integers between 50 and 500 which are divisible by 7. Let us start making a list of integers between 50 to 500 which are divisible by 7. The sequence is 56, 63, 70, 497. Here, the first term A is equal to 56, D is equal to 7 and AN is equal to 497. We know that AN is equal to A plus N minus 1 into D. Substituting the values, we get 497 is equal to 56 plus N minus 1 into 7. N minus 1 is equal to 497 minus 56 divided by 7, that is equal to 63. So, n is equal to 64. So, there are 564 integers between 50 and 500 which are divisible by 7.